Okay, logic test review. Here we go. Make a conjecture about the next item in the sequence. So just look at the pattern. So from 15 to 12, that's minus 3. 12 to 9, that's minus 3. 9 to 6, that's minus 3. So 6 to the next one should also be minus 3. And 6 minus 3 is 3. All right, number 2. What is the hypothesis? Hypothesis is going to be P. If it's raining, then it's cloudy. So the first part, or the part that comes after the word if, is the hypothesis. The part that comes after then is the conclusion. So it is raining is the hypothesis. Number 3, what is a conjecture? Conjecture is just a conclusion. Which of the following is the inverse of? Okay, so first of all, inverse is when you have not P, not Q. All right, so let's figure out what P and Q are. So let's see, if you fall. Okay, so that's going to be P. So we're looking for if you not fall. If you don't fall, if you do not fall. So A is wrong because the fall part is at the end. B looks right if you don't fall. C, if you don't break your arm, came first. The fall part goes second, so it's not C. And then D starts with if you fall. So these two are both automatically incorrect because it's supposed to start with P. D is incorrect because it doesn't say not. So B is the correct answer. Which of the following is the converse? Don't forget, converse is when you switch Q and P. So P is going to be if you go to GCM. So going to GCM is P. That is the hypothesis, aka P. And then Patriot is going to be your Q. So let's see what we got here. If you go to GCM, so there it is. If you don't go to GCM, there it is. I'm just highlighting all of the GCM parts. All right, so converse means you have to switch. And now the GCM part should not go first, but it should go second. The only one that has it second is C. C says if you are a Patriot, then you can go to GCM. So yep, it switched. All right, so we're good. Number 6, which of the following is the contrapositive? All right, contrapositive is when you have not Q, not P. So they not only flip or switch places, but they both are negated. They both should have not, or the opposite. So again, I'm going to start by highlighting P. That's going to be my strategy for this entire review. So I highlighted P, and then this part over here is Q. The unhighlighted part is Q. All right, so Baytown is P. So don't live in Baytown, that's P. Don't live in Baytown, that's P. Go to Baytown, that's P. And then that's P. Okay, so I highlighted all the parts that have to do with Baytown. Now, 3 of them have P as the second part, as the conclusion. B has it first, so that's automatically wrong. Now, it has the squiggle in front, so that means not. All right, and A is the only one that has not. I mean, do not means don't, so it's the same thing. C and D don't say not, so those are both incorrect. Number 7, which of the following is a true conditional? Okay, conditional means if P, then Q. A horse has 4 legs. So we have horse and then 4 legs. So this is going to be P, this is going to be Q. All right, so A is already wrong because it doesn't start with the word if. B is wrong, it doesn't start with the word if. So now we're between C and D. So horse is supposed to go first. So the one that is better is D. C is not quite it. We needed horse to be first and legs to be second. You want to go in the same order as the original statement. Okay, number 8. Which of the following is always true and can be written as a biconditional? Don't forget, a biconditional is going to go either way, meaning P to Q, or Q to P. And it's going to use the words if and only if. So now let's take a look through these answer choices. A is already wrong because it starts with the word if. B is wrong because it starts with the word if. Oh, sorry, hold on, brain fart. we're not looking for the biconditional. We're looking for the one that can be written as a biconditional. So that means we need one that is true forwards and backwards. Sorry about that. A says if two angles are adjacent, then they share a side and a vertex. So if we read it backwards, if two angles share a side and a vertex, then they are adjacent. That one sounds pretty good, so I'm going to put a check next to it. If a shape has three congruent angles, then it's a triangle. If a shape is a triangle, then it has three congruent angles. That is not always true. You can have a scalene triangle that has three very different sized angles, so that one's not always true. So it's sometimes true, but not always true, so I'll put a slash. If a shape has four right angles, then it is a square. Well, what about a rectangle? So that's not true, or that's not always true. All right, if two angles are a linear pair, then they are adjacent. That's true, but if you put it backwards and say if two angles are adjacent, then they are a linear pair, that's not always true, because you can have an angle that looks like this, and then you break it up into two angles. Now these two angles are adjacent, but they're not a linear pair, so that's not always true. So the only one that's always true is A. All right, sorry for the confusion on number 8. Number 9, which of the following is the biconditional of if a shape has three angles, then it is a triangle? All right, so we need the biconditional. So this one, we're actually looking for the biconditional. So again, we're looking for if and only if. All right, triangles have three sides. Nope, that doesn't say if and only if. Neither does this one. A shape has three angles if and only if it is a triangle. Yep, that one looks right. And this one says if then, so that is not correct because it says if then, so that's not it. So C is the only one that is a biconditional. All right, for this one, you will need to fill these in. So if you see this on the test, just fill them in. So the first one is given. That's always how it starts. The first one in these algebraic proofs, if y'all remember this from the first week of school, these are always given. All right, the second step. How do we get from the first step to the second step? Well, we got there by using distribution. So just demonstrate that. We use distribution, boom, and that's how we got 18 and 48. So that would be the distributive property. Okay, and then next, how do we get to the next step? Well, looks like we subtracted 48 from both sides. So that's going to be the subtractive property. And then next we have, how do we get to this step? Well, looks like we divided both sides by 18. So that would be the division, or the division property. And then last but not least, how do we get from this step to this step? Well, you just swap the places. We call it the reflexive property. Think of like a mirror, how a mirror swaps your right and your left. All right, so there you go. All right, next problem. These are a little out of order, sorry. Use the law of syllogism. Okay, syllogism means same to make a valid conclusion. So if two angles are acute, then their sum can never be 180. If two angles can never have a sum of 180, then they can't be supplementary. So don't forget, you cut out the middleman for syllogism. So both of these say the same thing, so cut it out. And now what are you left with? If two angles are acute, then they can't be supplementary. Okay, so that's what we're left with. All right, so obtuse angles are supplementary. That's not always true, so I'll put a slash. Supplementary angles are acute. That's not always true. One is obtuse and one is acute in a lot of cases. Acute angles are supplementary. It just said that that is not true. If two angles are acute, then they can't be supplementary. That's exactly what it said. All right, so if you see, that is exactly what it said. If two angles are acute, then they can't be supplementary. It's the same exact thing. All right, next problem, use the law of detachment. Okay, so now detachment means like different. So this is the time where you don't cross out the same parts because they don't have the same parts. All right, if you are tardy 3 times, then you must go to detention. Sophie was tardy 3 times, so Sophie needs to go to detention. Alrighty. Next problem. Okay, so a conditional statement is given, label the related conditional. So the related conditionals are just converse, inverse, contrapositive, and then state the truth value of each. Truth value is just true or false. So again, that's just true or false. That's what truth value means. All right, if two angles are a linear pair, that's going to be P. Then they are adjacent. That's going to be Q. All right, so let me start by highlighting. So two angles are not a linear pair, so I'm highlighting all the linear pair parts of each of these statements. Okay, so the first one, I highlighted the first part, so that's going to start with P. However, this one says not, so put a squiggle. And then it says, then they are not adjacent, so that's not Q, because remember, Q is the part about being adjacent. Now, the second part starts with the adjacent bit, so that's going to be Q. But again, it says not, so put a squiggle in front. Then you're going to put the arrow, of course. And then the next one says not a linear pair. Don't forget, linear pair is P, according to, the original statement up here. But it says not, so put a squiggle in front. Last but not least, this one starts with Q, and it ends with P, because that's the part that I highlighted, and neither of these say not, so there's no squiggle down here. All right, now that we have all this together, all right, this one is obviously the conditional. So the original is obviously the conditional. Now, A says not P, not Q. So if you look on your notes, you should see that that would be inverse. The next one says not Q, not P. And if you look on your notes, you should see that that is contrapositive. And the last one says Q then P, and you should see on your notes that that is converse. Okay, so that's probably, that's it. Yeah. All right, next problem. Make an illustration and use inductive reasoning to make a conjecture about the given statements. The angles in a triangle have a sum of 180, so they have to add up to 180. So sum means add. And then in triangle ABC, so let me draw triangle ABC, we have a 45 and a 45. Okay, so 45 plus 45, that's a 5, is 90. And if we take 90 away from 180, we get another 90. So this was angle A, this was angle B, and this is angle C. That's the missing angle that they didn't tell us yet. So if I draw a triangle that has a 90-degree angle, it looks something like this. It should be a right triangle. So there's my 90-degree angle, which was C, don't forget. And then A and B are both 45-degree angles, and since they are congruent angles, I'm going to put the little arcs in there. That's A and that's B. All right, so the conclusion, because it told us to make a conjecture, so the conjecture or the conclusion is that the measure of angle C equals 90, or you can say that triangle ABC is a right triangle. So anything like that would work.